This is walkthrough video of my Kaggle assignment 3 notebook, and the objective is to build model to predict sentiment of movie review given by user on a movie review platform. In the dataset we have ID, phrase which is review text of the movie, feature 1, feature 2, feature 3, and sentiment. And sentiment with 0 means negative, 1 for neutral, and 2 for positive. Starting with importing the data, we have imported as train, the training data, and test, the test data. Now first is identifying data types of different columns. So we have integer, object, and float data type in this whole data set. ID is integer, phrase is object, and feature 1, feature 2, and feature 3 are float, and sentiment is also integer. Now descriptive statistics. So for feature 1 we have maximum value of 52. For feature 2 the max value is 19, and for feature 3 as well. So the count is 6088 and 5896. This means we have some null values. Missing values, if we talk about, in feature 1, 2, and 3 we have some null values in train dataset as well as in test dataset. I used fill NA and using median. Now handling duplicates, so we don't have any duplicate rows here. Outliers, if we talk about outliers, we have few outliers in feature 1, feature 2, and feature 3, and the number of outliers are 122 in feature 1, 842 in feature 2, and 331 in feature 3. Visualization part, so I used word cloud here. I created the list of most frequent words based on the TF-IDF score. So these are the top 20 words based on these are the top 20 words based on TF-IDF, film, movie, like, story, and all these words, and the graph for these words and their TF-IDF score. So film has the most TF-IDF score, which is around 0.028, 0.023. Now phase length distribution. So we can see this graph is somewhat right skewed. This means in our data set most of the phrases have short length, so few are which have long length. Now if we have for sentiments, so this is the frequency of sentiments. For negative we have 2864, for neutral we have 1344, and for positive we have 2972. so this is the graph for that. Now scaling features, feature engineering part. New columns introduced in this are phrase length, word count, average word length, improving the phrase column. So we are using regular expression here and removing the unnecessary punctuations we are keeping only the important ones like exclamatory mark, question mark, then slash. Now scaling, we used standard scalar on this numerical columns. For the phrase we are using TF-IDF vectorizer. So now after we are stacking this train text and train scaled here. Train text is this one after using TF-IDF, train text, and train scaled after using standard scalar. Splitting the data, we used test size 0.2. Now model building part. The 7 models I used is logistic regression, KNN, decision tree, random forest, linear, SVC, then SVC, and gradient boosting classifier. So for logistic regression, the accuracy is 0.54, for KNN 0.43, decision tree 0.46, random forest 0.524, linear SVC 0.547, SVM 0.522, and gradient boosting 0.51. Now the three models I choose for hyper tuning are logistic regression, and the accuracy is 0.45, sorry, 0.54. Then linear SVC with accuracy of 0.5498. For final prediction, I used grid SVC. That's all. Thank you.